Hello and welcome back. This is a new lesson where we look at multitasking threads. Multitasking threads are useful for creating a multi-threaded red. Why do we need to have multitasking threads? Let's take a look at our previous design for our red. On the left we have our client, and in the center is our server red. The server red has got a message loop, which is actually a while loop which runs perpetually. So when the client sends any messages, it will send it to the server red, which will then receive it and process it. The problem with this design is that while the server is processing the first message, if the client were to send a second message, it will be held in the queue. It will not be processed immediately. So the second message will need to wait for the first message to complete. That means if the first message is displaying a message box, the message box will have to be closed by the user before the server can process the second message. And if you have multiple messages which can be received by the server, they all need to be held in the queue to wait for their turn. So that is a distinct disadvantage for the server. It would be ideal if we can have a server that can process messages concurrently at the same time without having to wait for the first one to complete. So that concept is known as threads. We can use threads in order to accomplish that design goal. So in this old design, you notice that I've put a double-headed arrow here, which means block. So this is called blocking design. Blocking design is where a process runs sequentially from top to down, and it cannot proceed to the next one unless the first one has completed. So if you take a look at the code for the earlier design, you will see that this is where the blocking happens. So in a while loop, if the client were to send a message M, then the server will call the message box to show the hello world. And whilst it is showing the hello world, if the telnet client were to send another message, let's say B, to beep a sound, it will not happen. It has to wait for this instruction to complete. The message box must complete, must shut down, must close before the server can go ahead with the second message B. So this is called blocking mode. So this is a major disadvantage for servers. So let's see how we can improve on that. Now this is another new design, multitasking threads red. On the left you will see the client as usual, and the client can send messages M for showing message box, B for beeping, and Q for quit. Now we are introducing a new technology here, which is called threads. So threads are mini programs. You can view them as mini or small programs running within the main program. The main program is called a process, and inside a process you can have many threads. Each thread can do one task, and they do not block each other. They can run concurrently. So that is what we mean by non-blocking. So if the telnet client were to send the message M, the server can spawn a new thread to handle the message M, to show the message box. And whilst the message box is still being shown and has not yet been closed, and if the client were to send a second message M, the server can spawn a new thread to show a second message box even though the first message box is still on screen. And the client can keep on sending as many messages M as he wants, and it can spawn as many threads as it needs to show all the message box at the same time. And the client can also send B, a beep command, in order to sound a beep even though the message box is still being shown. So this is the beauty of having threads which can solve our design problem. So let us take a look at the practical example of this problem in the old design. So let's go back to our earlier design, which is the blocking mode design. So let us run this now and see the problem for ourselves. So now the server is running. We will open a command prompt and telnet to our server. So now it is connected. Let us open the message box by pressing M and hitting enter. Now the message box is showing. Let me try to send another message M. I'll click in here and I press M and I press enter, but nothing happens. The first message box is still there. Second message box is not showing. Now let me try to send a message B to sound a beep. So I click in here and I press B and I hit enter, and no sound could be heard. That means this program is blocking at the message box. So it is blocking over here. That's why the second message box was not shown and the beep also was not shown. So see what happens when I dismiss the first message box. When I dismiss the first message box by clicking OK, the second message box shows. Now let me close this again, click this and see what happens. And now the beep sounds. So you can see all the messages that are received by the server is held in a queue waiting for its turn. So this is a distinct disadvantage of a blocking server. We call this a blocking server because it is blocking each other. Each message, each task is blocking each other. So now that we know how to solve this using threads, we will proceed in our next lesson to design this multitasking thread red. So thank you for watching. I'll see you in the next lesson.